Hello viewers, you're welcome to Human's Media for another exciting moment. Today we are going to be having another wonderful class, and today's class will be on conversion of other bases other than base 2 to base 10. Previously we have done introductory part of number bases, and we have done conversion of base 2 numbers to base 10, both whole numbers and decimals. So today we are focusing on other bases other than base 2, so that you will see that it's not only base 2 numbers that can be converted to base 10, but other bases can as well be converted to base 10, both whole numbers and decimals. And before we proceed, in case this is your first time of visiting this channel, I want you to consider hitting the subscribe button and also turning on the bell notification. Like and share this video so that anytime Human's Video drops an awesome video, you are going to be notified that yes, there's another awesome video waiting for you, and you don't have to search for it before you can locate this channel. Today we are looking at conversion of other bases other than base 2 to base 10. We're going to be taking two examples for today. The first we have is 3212 in base 5. We're going to be changing this number to base 10. In this topic, we have learned that what we do is continuous multiplication, and that involves multiplying each digit in the number by the base raised to the power of the position of the digit minus 1. Now in this case we have 4 digits, 3212 minus 1 gives us 3, and so we have 3 here raised to power 3, raised to power 2, power 1 and 0. So let's do the multiplication. So here we have 3 times 5 raised to power 3 plus 2 times 5, which is the base, raised to power 2 plus 1 times 5 raised to power 1 plus 2 times 5 raised to power 0. Like I've explained initially, the essence of this subtraction is so that the last digit will be raised to the power of 0. Let's go. So here we have 3 times 5 raised to power 3 is 5 times 5 times 5. That gives us 125. We put a bracket here, plus 2 times 5 times 5 is 25, plus 1 times 5 raised to power 1 is 5, plus 2 times 5 raised to power 0 is 1. Any number raised to power 0 is 1. That is the law of zero index. Okay? Now 3 times 125 is going to give us 375 plus 2 times 25 gives us 50 plus 1 times 5 is 5 plus 2. Okay? Let's do our addition. 375 plus 50, that gives us 425 plus 5, 430 plus 2, 432 in base 10. Wow! So we've been able to convert 3212 in base 5 to base 10, and that gives us 432, which is our daily counting of numbers. Now the second example we are going to look at will be a decimal. So we'll also see how we can convert a decimal that is not base 2. So the second example we're going to take is 12.33 in base 4. Now we're going to convert this number to base 10. Let's follow the same approach we have always followed. Here is 1, 2, that is 12 in the whole number part, which is 2 digits. 2 minus 1 gives us 1. So here will be raised to power 1 raised to power 0, meaning that here in the decimal part will be minus 1 and minus 2. So let's expand. So we have 1 times the base 4 raised to power 1 plus 2, the second digit, times the base raised to power 0. Now the number is not too long in terms of digits, so we can proceed with the decimal part. Plus 3 times 4 raised to power minus 1 plus 3 times 4 raised to power minus 2. 4 raised to the power 1 is 4, so 1 times 4 is 4. Plus 4 raised to the power 0 is 1. 2 times 1 is 2. Plus 3 times. Now this is a negative index, 4 raised to the power minus 1. And according to the law of negative index in indices, we are meant to understand that this will be equal to 1 all over the base raised to the power of the positive index. And that is 1 all over 4 raised to the power positive index of minus 1 is 1. So we have 1 all over 4 raised to the power 1. Plus, here we have 3 times. We do the same thing. We have 1 all over 4 raised to the power the positive index of minus 2, which is 2. Okay, so here we have 4 plus 2 gives us 6. Plus 3 times 1. Remember, this is all over 1. All over 1. 3 times 1 is 3. 1 times 4 raised to the power 1 is 4. Plus 3 times 1 is 3. 1 times 4 raised to the power 2. 4 raised to the power 2 is 16. So we have 16. Now at this point, we are going to solve this problem using the procedure for solving addition of fractions. I'm going to drop the explanation of the steps at the description of this video. Do well to check the description of this video to get that. We're going to take the LCM of the denominators. And here the LCM of 1, 4, and 16 is 16. We have 6 the numerator here, multiply the quotient from 1 divided 16 gives us 16. 1 divided 16 is 16, so we have 6 times 16. Plus the numerator here, 3 times 4 divided 16 gives us 4. So we have 4 here. Plus the numerator here, 3 times 16 divided 16 is 1. 6 times 16 gives us 96. Plus 3 times 4, 12. Plus 3 times 1, 3. All over 16. 96 plus 12 gives us 108. Plus 3 gives us 111. All over 16. Now 16 divided 111 is going to give us 6. That is 6 times 16 will give us 96. And 111 minus 96 gives us 15. So we have a remainder of 15. So we have 15 all over 16. Now this is in base 10. Wow. You can see that we have arrived to the solution of this problem. This is to show us that other than base 2 numbers, we can convert every other base 3, base 4, base 5, base 6, and so on, all to base 10. I want you to take time and watch this video and watch the previous videos. In case you are confused anywhere, you are free to ask questions at the comment section of this video and I'll be there to attend to it. Thank you. See you in the next class.